Welcome to Ms. Taylor's class notes today. Today we're going to look at some more attributes of quadratic functions. So, they're asking us to find symmetry in the shapes to the right, A, B, C. So symmetry tells me that it cuts it in half. So if I have an isosceles trapezoid, I can cut it in half there. If I've got a square, I can fold it that way and it's cut in half. And I also can cut it this way and it's in half. And if I have a shape like a kite, I can fold it in half right there. So our line of symmetry, it allows us to cut a shape, it's a bad writing, shape in half and have it be the same and on both halves. So parabolas also have lines of symmetry. And where those lines of symmetry are going to be through the vertex. So we're always going to be able to cut a parabola in half at the vertex. And so what that means is that this point here and this point here are the same distance away from the axis of symmetry. Same thing goes for these two. They're the same distance away because that line cuts it in half. So again, we're always going to find the vertex, and that's going to be where our axis of symmetry is, and everything on either side of that line is going to be the same distance away. So, all lines have a line of symmetry, and we call that line of symmetry our axis of symmetry. So let's talk about our axis of symmetry real quick. Our axis of symmetry in Algebra 1 is always going to be a vertical line. When you get to Algebra 2, you'll have some non-vertical axis of symmetries. But remember, if we have a vertical line, that tells us that it is a vux, which means that it is undefined and its x equals. And again, our vertical line or our axis of symmetry is always going to pass through the vertex. Each point on a parabola will have a point with the same y value and the same distance from the axis of symmetry. Think of these points as mirror images of each other. So, when we look at our graph right here, our vertex is always going to be our highest or our lowest point, and then our axis of symmetry is going to go through the vertex and divide the parabola in half, and all the points are going to be the same distance away, or like we put in our notes, mirror images of each other. So, we're going to work on finding our axes of symmetry. So the first step is going to always be to find that vertex. So this vertex is -2, -7. We said our axis of symmetry are vertical lines, which means it's vux. So that key right there tells me x equals, and then I'm going to go find the x value of the vertex. So it's x equals -2. And if it helps, you can draw it and then see where it crosses the x-axis, which again is the x value of the vertex. So, we're going to again find our vertex. That's always step one. Find that vertex. So if we notice here the graph, they're counting by halves. So our vertex is going to be 1.53. And that doesn't really change anything for us when we do our axis of symmetry. Again, it's going to be a vertical line, which means it's a vux. And vux means x equals. So it's x equals. And then we're going to look at that x value of our vertex, so x equals 1.5. So it's really easy for us to find axis of symmetries when we're given a graph. But if we're not given a graph, we do have a way that we can find them. So when our function is in standard form, f of x equals ax squared plus bx plus c, we can use this formula right here. X equals -b divided by 2a. So the answer to this is the x-coordinate of the vertex. So we're going to find the x-coordinate of the vertex, and when we do that, we'll be able to know where our axis of symmetry is. So they give us this function here. f of x equals x squared plus 8x plus 13. We have our a, we have our b, and we have our c. So our invisible number in front of a is 1, our number in front of the x is 8, and then our constant all by itself is 13. So now we're going to plug everything into our formula. X equals negative b over 2a. So our b value is 8. I'm always just going to kind of keep that negative in front of the parentheses, but you can put it with the 8 if it makes it easier for you to understand. I'm going to put my 2, and then I know that my a value is 1. So now I need to multiply 2 times 1, which is going to get us a positive 2, and now I can simplify my fraction. So I need to make sure I have that negative, and 8 divided by 2 is 4, which equals x. So this right here is our axis of symmetry. And if we were to go look at our graph, we find our vertex, we draw our line, and yep, that is true. We now have our vertex. But now that we have our vertex, or the x value of our vertex, we can, without a graph, find our y value. So we're going to write the equation that we were given, and I'm going to change the f of x to y because a lot of the times it's just easier to do y in this situation. I'm going to write x squared plus 8x plus 13. So we know what our axis of symmetry is. We know what the x value of our vertex is. So I'm going to take this negative 4 and I'm going to replace every single x in the equation with negative 4. So y equals negative 4, and it's going to be really important that we put that negative 4 in parentheses every time we write it down, because the squared, the negative needs to be in that parentheses for when we square it. So negative 4 times negative 4 is going to be a positive 16. 8 times negative 4 is going to be a negative 32, and then we're going to put plus 13. So 16 minus 32 is going to be a negative 16, plus 13 is going to be a negative 3. So our y equals negative 3. So now we know what our vertex is. Our vertex is negative 4, comma, negative 3. Because, again, we just did the math to find it. And we can check in the graph, and yep, on the graph it is negative 4, negative 3. So they gave us an equation. So again, we need to find our A, our B, and our C, and we need to plug them into our formula. So negative, and then I'm going to put negative 20 is my B, 2 times A. So we're going to simplify this. We're going to go negative 20 over 4. We're going to simplify our fraction. So we get a negative 5, and a negative times a negative is always a positive. So our x equals 5, so that means our axis of symmetry is x equals 5. And then to find our vertex, we're going to plug it back into the original equation. So y equals, and again, I'm going to replace all of my x's with 5. 5 squared minus 20 times 5 plus 51. So 5 squared is 25, times 2 is 50, negative 20 times 5, 20, 40, 60, 80, yep, negative 100, plus 51. Let me actually put 51 instead of the number 1. And so we should have a y that equals 1. So our vertex should be 5, comma, 1. All right, again, we always want to identify our A, our B, and our C, and then we can plug it into our equation. Negative parentheses, my B is negative 8. I'm going to write down the number 2, and my X is negative 1. So 2 times negative 1 is going to be negative 2, and then I always need to make sure I have that negative from the equation. So negative 8 divided by negative 2 is going to become a positive 4. And so our answer is negative 4, which makes our axis of symmetry x equals negative 4. And now we can plug all that information in. So negative parentheses negative 4 squared minus 8, negative 4 minus 8. Let me put that y equals there. So a negative 4 times negative 4 is 16, but I still have another negative, so it's going to be negative 16. A negative times a negative is a positive, which is a positive 32. And then we have minus 8. So a 32 minus 16 is 16. 16 minus 8 should be 8. And so now we have our vertex, negative 4, 8. All right, I want you to do this one on your own, but I'm going to point out one key thing here. Our A is always in front of the square. Our B is always in front of the X. And if there is no C, our C equals 0. So go ahead and check this with the completed class notes. All right, I'm going to give you one key piece of information before you do this. So it's asking about quadrants. So when we talk about graphs, we talk about quadrants as having we make a C with our quadrant. So we're always going to start with quadrant 1, and then if we follow the path of our C, next is quadrant 2, then we have quadrant 3, and then finally we have quadrant 4. And again, those are just Roman numerals. And if we're in quadrant 1, we know our point is positive, positive. Both the X and the Y are positive. In quadrant 2, our X's are negative, but our Y's are positive. I'm going to add that piece right there to help you out. Let's make an actual parenthesis. In quadrant 3, our point is going to be negative, negative. Both the X and the Y are negative. And then finally in 4, it's going to be positive, negative. And so that's just a real quick thing to help you answer this question that you should have learned before, but I don't know if we've gone over it anytime soon. And then finally, I want you to do this last one on your own and check your last 3 answers with the completed class notes.